So arguably the two biggest trends that are facing our industry today are sustainability and urbanization. I'm not going to go into sustainability too much. We've got some great tools for that if you're interested. But I'm going to talk a little bit about urbanization. So hopefully you're all aware of the sort of growth in our population and the challenge we have over the next 30 years to try and house this massive explosion that's about to happen, particularly around cities. If you've attended Autodesk University or seen a presentation from an Autodesk exec recently, you would have heard that. And more importantly, you would have heard about the number of additional buildings we're going to have to build from now to 2050 to accommodate people. Which is really the first trend I'd like to talk about, because as a result of that, there's this huge growth in vertical infrastructure. And when you combine the challenges that we have around population growth with developing economies asserting themselves around the world, you end up with tall building and skyscraper boom. And you know, it's been happening for a while now, and this sort of slide illustrates that. You can see some of the tall buildings that we've erected over the last few years, going back to the Freedom Tower in New York City, 2004, Shanghai Tower, 2009, and the Jeddah Tower, 2015, all of which incidentally use BIM and some of our technology as well as others. And what's interesting about that is that we've seen a whopping 400% growth in these types of projects since the year 2000. 76% of that growth has been in Asia, and 53% of it has been in China. And what's really interesting is that China have got another 16 projects like that on the cards going forward. One of those projects I'm going to talk about in a moment, but before I do, has anybody not seen this video? That's what I thought. Oh, you haven't? All right, well, you're in for a treat. I'm not going to play it all, but this is a fantastic video that actually came out in 2012. And it's the Broad Group, and they did what was seemingly the impossible. They constructed a 30-story tall building in just 360 hours, or 15 days. Now that wasn't in its entirety, you know, the fit out, etc. But for the most part, it was constructed like this using modular prefab. And what was really interesting about this too was it met some very lofty goals in terms of sustainability, quality, and all those kinds of things. This is on YouTube, and if you haven't seen it, I would certainly recommend you take a look. But if we fast forward to today, and this is a project called China Zun. So China Zun is a CITIC Hay project. It's a $3.5 billion project in Beijing, and it's breaking a number of records. The first being that it's the first skyscraper to be constructed in a seismic area. Not a massively seismic area, but it's nonetheless seismic. And it's pretty tall. It's over 500 meters tall. It's got 108 floors above the ground, 7 floors below the ground. And it was constructed, or will be, it's actually going to be completed later this year, a lot faster than any other project to date. So roughly around 62 months for a building of this size and capacity. And what's really interesting about this building is how they've approached the project and how they've managed to build it. So they've used things like simulations, CFD solutions, you see on the bottom left-hand side there, to really look at sort of how the building is going to perform under certain conditions. So wind pressure, distribution, daylighting, solar, natural and artificial lighting, all of these kind of things have been simulated early in the design phase. They've used modular construction, prefabrication. In fact, they managed to reduce site time by 30% and reduce waste by 90% in the construction process. And they also managed to reduce the use of water and electricity by 20%. So massive sort of savings on a project of this scale and of this kind. They use tools like Navisworks to simulate construction sequencing, construction concrete pours. They used recap software to do scanning. You heard Amanda talk about that. They did that daily to find out exactly where they were on the project in terms of completion, to see what errors were occurring, to see where they were in relative to the digital twin that had been created, and also to help address and identify issues. as well as using it for QA/QC much later on in the project as well. They use Dynamo for computational design for a lot of the architectural features you see on the external part of the building. So they're able to come up with these very complex structures and then push that out to CNC for pre-assembly before it was delivered to site. And then finally, they used a lot of sort of mobile devices throughout the project to just keep the teams coordinated as they went. So there are two really big sort of trends I think that I see here, apart from the ones I've just mentioned. One is the use of simulation tools, in particular CFD, and the other one is computational design. So as I travel around the world, one of the things that I'm seeing a lot more use of is simulation for things like this. And it's really allowing the engineers to be pulled into the process in a way that they haven't been before. So up until now, Revit's been very much a geometry tool, coordination modeling tool, but that's really beginning to change. CFD was always the purview of the specialist. You know, it was a very expensive software. It was certain people that had the skill sets. Now you can take a Revit model, push it into CFD and start doing the kinds of things that you're seeing here. So you're able to sort of do it in a very integrated way that can ensure compliance, help mitigate risk, and improve occupational efficiency as well. So when you look at sort of some of the things that are happening around the world today with, you know, a focus on wellness, occupational sort of health, and that kind of thing, the need to sort of use these tools to simulate for things like natural lighting, natural ventilation, etc., are becoming increasingly more important. And that's where we're seeing engineers really starting to engage in the process. It's used typically on hospitals, obviously, data centers, tall buildings, which I've just talked about, but it's actually being increasingly used on commercial, institutional, and educational buildings as well. Going back to the use of computational design, this is a project, again in China actually, Guilin Lianjiang International Airport, that used, again, a lot of simulation, but also a lot of computational design. This time not to just kind of automate tasks, which people typically associate with things like, you know, Dynamo, Rhino, Grasshopper, things like that, but to actually create specific forms, very complex problems being solved by very complex forms, as you see in the top right-hand side there. And then being able to sort of link that model with analysis software using something like Dynamo to connect different tools and to connect different processes to drive informed decision-making in ways that, you know, are becoming fairly standard now, but in the past, some of them weren't even possible. So you see some of the savings there, 20% reduction in detailing time and overall sort of labor-saving costs. So it's pretty interesting. This is Perkins and Will working with Georgia Tech. And what they're doing is, again, using computational design tools to basically analyze a hospital building, working with a particular hospital trust. And what they were able to do was to take the model and start looking at different ways in which they can arrange the rooms. So what they wanted to do was put all these patient recovery rooms, if this works, around the outside of the building, because the more sort of exposure they can get to natural daylighting and views from outside, the quicker they're likely to recover. There's medical evidence to suggest that that's going to help with you know, recovery. And so this process was allowed them to run many different iterations over and over again and look at different scenarios on how they could position these rooms where they needed them to. But if you think about this and how you can use this type of technology early in the design phase, you can really change the discussion with the client, because to a hospital trust, the thing that's important is where are rooms located relative to particular tasks. If you can put waste next to a theatre rather than the other side of the hospital, not only are you going to save time in moving that person from one room to another, but you're going to potentially reduce the risk for things like contamination and other things. So this is where rules start to come into, you know, the design process and really change how you're not just designing, but how you're having a conversation with the client. What you then do is take your Dynamo script, which most people have been running on their desktop for a while now, and you pop it up in the cloud into something like Fractal. And we're seeing an increasing use of this. This is free. This is something you can try from Autodesk. It's in the cloud. You take your Dynamo script, you pop it up there, and you can run multiple iterations based on certain design criteria. So in the top left-hand corner, you can see that we can start pushing and pulling this model based on certain key metrics. So do we want to, I don't know, price could be one of them, certain types of configuration. Depending on your scenario, you can start interacting with the design in ways that people haven't been able to do before. And of course, what typically happens on a design project is you design for the worst case, you take that one example, worst case, and you assume that that can be applied everywhere else. This is really beginning to design with true activities in mind, pure activity-based design. So, as always, what we did was, recently, when we were moving office, we decided to eat some of our own dog food and use this technology to see how it could help us. So we recently moved office in Canada. You see over there in the left-hand corner, the Mars building. And what we wanted to do was see if we could improve the environment for our own employees, improve productivity, improve collaboration, and buzz. And so we had certain metrics to look at, sort of adjacency preferences, people's work styles when they were in an office, when they weren't, lighting, natural versus artificial, that kind of thing. And so what we did was we ran a series of surveys with our employees, and we asked them, who do you like to work with? Who do you need to work with? How much is it important that you get a nice view from the window? How close do you want to be to the kitchen? If we go back to Andrew's example this morning about that worker at Heathrow T2 who didn't like that terminal because it wasn't close enough to the tea room. Well, here you go. Here's your solution. This guy can start telling us exactly where he wants to be and why he needs to be there and why that's important to them, but also why it's important to us as an employer. So these were the 8 criteria that we came up with. We wanted to check for all of these views to the outside, acoustic distraction, et cetera, et cetera. And so what we were able to do was run a series of, oops, I didn't know that played music, so apologies. A series of scenarios. The blue boxes are offices, the yellow ones are desks, and we can run many, many different types of iterations based on this criteria. And then we can look at how it scores against what we're trying to achieve. So in terms of daylight, scored pretty good on certain examples. Adjacency preferences, not so good. So if you imagine how this changes, as I say, the conversation you have with the client, or how you design a building, or how you become more competitive as an organization, these are pretty powerful tools, which is why we're seeing them being employed more and more by people around the world. And what's interesting is it's not just design, right? So we'll talk a little bit more in a moment about DFMA, but this is pushing downstream into the construction industry. So this is a crane, obviously. And so when you start thinking about cranes in construction sites, you think about what type of crane, to do what, lift what load, where should it be positioned, what's the sort of turning radius of it, and what can not be positioned relative to it, or what should be positioned relative to it. And you can start iterating over those examples, multiple crane scenarios, lay down areas, et cetera, et cetera. So it's a really, really powerful way of starting to use data in a way to inform decisions. Moving into the construction sector, we're still seeing a lot of modular prefab. You've been doing a lot of this in Australia, so it's no real surprise to you guys, I know. But yep, there's a lot of modular racks, risers, and that kind of thing that's sort of being used around the world. It's particularly strong in China, the Middle East. It's been in Europe for 20 years in different shape or form, starting usually with pods. And we're starting to see it take off in the US as well. What's interesting about this, in countries where it has been for a very long time, there's still very few standards around it. But nonetheless, it proves relatively popular. Here's an example from MC Dean, doing just that, doing the thing that you guys do. And of course, they're doing it for a very specific reason, right? So they want to be able to control things like cost, material, labor, safety, time, efficiency. All those kinds of things are super important to these companies. And I talk to companies that say, look, we have a strategy to move on-site construction off-site by a certain year by a certain percentage, 60% off-site, 80% off-site. And yeah, that makes a lot of sense for the reasons that I just gave. The challenge is it's really sort of automating a fairly traditional process. So it's allowing multiple things to be done in the same place rather than people queuing up behind each other on site. And so that's great, but it actually doesn't do a great deal to increase the residual value to the client ultimately. It's not being designed in early enough, and that needs to change. So that's sort of really, for the most part, this is the trend of people adopting rather than necessarily thinking about what's next. However, it's fair to say that shop automation and off-site prefab is changing. This is a company in the Netherlands called TBI Voorbij. I don't know if anybody's seen this online. This is available on YouTube. It's also available on Construction News. It's pretty interesting. They used a lot of manual labor in their factory for many years to do concrete slabs and panelization. And until they invested in this level of automation, which is basically using machinery / robotics, arguably, to do exactly what you see here: concrete pours, structural rebar, using the robots to pick them up, lay them down, based on a series of rules that are driven from the Revit model. So you can estimate the amount of pour that you need and control that via this progress implemented machine. What's interesting is about the amount of people that they were able to reduce in the factory, so from a large number to a very, very small number, and then redeploy them into better roles. So this is where we see, things could potentially improve over what we're seeing in traditional modular prefab, where we've still got a lot of people working in those shops doing fairly manual tasks. In some instances, industrialization of construction processes is actually starting to change for the better. You've heard DFMA mentioned already this morning, and that's exactly what this is at a sort of housing level. So what it's doing from a pre-con construction perspective is doing the same things that you just saw there, so modular prefab, panelization, all of that's being done off-site, but it's actually being pulled upstream into the design process. So this is Project Frog, componentized design, manufacture, and assembly for DFMA. And it's basically taking buildings and the sort of construction logic for constructing those and pulling them into the design phase. So as they design, they're thinking about, what's it going to take to build this? What materials are we going to use? What's the availability of those materials? How are we going to construct it? How long is it going to take? And all that's being pulled up front into the design phase. This is just one of several companies that we're seeing starting to take this kind of highly customized, component-based approach to construction. One of the others is Katerra, who you may have heard of from the US. Katerra were, interestingly, a company that received some pretty huge investments from SoftBank recently and others, SoftBank, River Park Ventures. They invested just over 800 million, in this company, and what's particularly interesting about that is SoftBank are not very known for being in the construction business. So we're seeing a lot of people coming into the construction space, investing heavily in this type of technology. Another company that's doing something like this, but more on the commercial, institutional, and industrial level, which I think is probably leading where a lot of people are, is Bryden Wood. You had Jamie Johnson here last year talking about this. This is from their website. And basically, they have this concept of a chip which embeds a lot of knowledge around the design, the delivery, the manufacture of the building and the facility, broken down into specific spaces where they can put this in front of the client and start saying, what is it you really need? What does that configuration look like? What problems are you trying to solve? And so they're, again, bringing this design, manufacturing logic, pulling it up front into the design process to really inform not just the design, but ultimately the delivery of the building as well. And the final delivery looks a little bit like this. So this is a flat pack kit that goes to site. You see it's color coded, and obviously colors go to colors or as the instructions inform. And instructions are delivered electronically, so people know who's got those instructions, when have they opened them, when have they viewed them, and you can start to assess some level of progress electronically. And of course, what this does is it means you can reduce the skill you need on site. So you don't need very highly skilled people, and you don't necessarily need a lot of people. And using this component-based approach as well, you're able to sort of ship materials to the site with it touching less people. So less people, less cost, more residual value ultimately. So that's the goal here, is like, how quickly can we start getting these materials closer to production rather than taking it away and then delivering it. So this prefab thing makes perfect sense, but ultimately, what could we do potentially on site to enable construction? And 3D printing is potentially one of those things. And there's no shortage of examples of it out there. You've already seen some this morning. So in the bottom left-hand corner, 3D printing of buildings. This is from China. It's not mainstream. People are doing it. There are some goals from nations like in the Middle East, for example, that say by certain time, I think 2030, we'll be starting to 3D print concrete buildings. But it's experimental. It's interesting. We're doing a lot of 3D print, or the industry's doing a lot of printing with 3D around metals, different materials. Bottom right-hand corner is a pipe fitting manufacturer that produces some very odd-looking fittings that basically solve those problems that occur from time to time. And of course, steel at the top right, which was associated with that bridge in the Netherlands. So yeah, these things are happening. They're still fairly sort of exploratory, I guess. But they could change the way we construct if we could do a certain amount of this, or a lot of this, actually on the construction site, in situ where needed. And to that topic, we have things like robotics. So this is really interesting, actually. This is the first commercially available masonry robot in the world. It's the SAM 100. And basically what it does, as you can see there, is it lays bricks. It's capable of outperforming an individual by quite a lot. I think the average individual lays about 700 bricks an hour. This does 1,000. There is somebody else that needs to be, which you see kind of hidden in the back there, kind of cleaning things up. So there's this cobot kind of relationship. But this is what's happening today, and this is actually cited to be used on a forthcoming Zaha did project. So this is very real. It's not just a very nice experimental kind of gimmick. What's interesting is that there's it's predicted that approximately 240,000 new jobs will be created related to robotics in the EU by 2020. So this is a fast-moving sector that I think is wide open for disruption from a construction point of view. The trouble with robots, though, is that by and large, they're very static. So a lot of the robotics that we see, which you just saw there, was this numeric arm, the arm that moves and does what it's told to do. But it's very static. This is an example from ETH in Zurich. And this is kind of an experiment, as you see there, sort of with rebar, but it's being used on a real-life project called DFAB House Mesh Mold. And it's really interesting. It's being controlled, obviously, by somebody who you saw at the beginning of the videos, who can move them into a certain position, get them located where they need to be, and then, as you see, running a series of sequences that are pre-programmed. So very interesting, enabling the robots to move around the site, but still fairly sort of static in the sense that somebody else has got to control it. And so that's really the next step in sort of robotics, I guess, really, is learning how we can teach the robot to kind of do more things quickly. So the challenge we have today with robots is that they don't necessarily understand what's in front of them. They need that visual capability. They need to be able to put that into some context. And sorry, let me go back. Get ahead of myself. They need to be able to put that into some context, and they need the dexterity to be able to pick things up and move them about. And so being able to train the robot is the challenge. What's particularly interesting, this one I'm going to play? Yeah. About this is things like Doxil, which is this example here, which is relatively new. It's not the only sort of drover of its kind. It's one of many. But what this does is it goes out autonomously, runs across the construction site, and is able to understand how much work has been installed that day. So you can see here what it's doing is calculating the earned value, right? So it's saying, oh, you've installed this much duct, this much pipe, etc., based on what was in your model, right? Now, you could argue. People are getting scared now, Steve. Yeah. Now, you could argue you don't really need this, right? Because if you do your assemblies right, you do your packaging, your deliveries, your sequencing correct, you know what's going to get installed that day, right? So you don't really need this. Or do you? I don't know. But what's particularly interesting for me is the fact that what you're seeing is this autonomous thing that's moving around the job site. And we have actually a couple of customers that we're working with that are doing just that. They have robotics that can actually understand if a person's in front of them. There are robots that follow people and carry things. And there are also robots that work with other robots. So it's not mainstream, it's not going to happen tomorrow, but it's absolutely happening out there in certain cases. And of course, I won't talk about the drones. You saw the drones earlier this morning. More realistically, this is Skanska, and I know I'm running short of time, so I'll be quick. This is the world's first drilling robot, okay? Some of you may have seen this. Anybody seen this? So this is in use today in Norway on a hospital project. This is N-Link. And basically, this drilling robot is about 8 times faster than a man with a drill and a step ladder. It's also a lot safer. What's interesting is there's a guy following him as well. So there's actually there's a cobot kind of relationship there as well. But what drives this is Revit. So the control for all of this is coming out of Revit in the same way that it does go to your robotic total stations and allows you to lay out your hangars. Same technology is being used here to drive this particular robot. Just talk briefly about things like AR, VR. This is an example from J.E. Dunn in the US using the Autodesk Forge platform. And what's interesting about this is it's cheap technology, right? Here's a link to a problem I've got on my job site. The guy who's there has no clue how to solve this problem. So he sends the link via email to his mate on the other side of the job who can immerse himself in the project, understand what the challenges are, and help him to solve that problem. So when you think about the talent problem we have today with older people with a lot of knowledge leaving the industry and young people coming into the industry that really don't know enough about how to solve these kinds of problems, something like this becomes incredibly powerful. And it's simple. Google Cardboard, $10. And I think the last example I'm going to show you today is one from Gil Bain. You may have seen this one. This is the HoloLens. I don't think I've gone into a company recently that hasn't got the HoloLens or isn't doing something around AR, VR. You just heard Amanda talk about it. It's all quite experimental. Some of it is used to engage with clients, particularly on the design side. There's a lot of people exploring opportunities in the construction side. This is just one. This little project, which was really an experiment, saved Gil Bain $5,000 because they suddenly realized they actually had the wrong material for the job in hand. And this was an experiment with MIT. But there's a lot of people working on this. It's fairly cheap and accessible. And it really is starting to change the way we do a lot of things in the construction side. So to recap, these are the things that we're seeing most around the world from a sort of technology trends perspective. More use of simulation analysis, generative design helping to inform decisions, drive decisions, and do things that you just can't because you don't have the time or the resource to do that. Industrialization of construction and DFMA. DFMA is huge. It's just going to get bigger and bigger. And using generative design to pull that construction logic in upstream is really going to sort of be something that's going to pick up over the next 5 years or so. And be prepared. I mean, the robots are coming, right? They're definitely going to be helping us to do things a lot smarter on the construction side. It's probably going to take a few years, but it's happening. So I think hopefully I've pulled it back in time. Thank you very much for listening. I hope you found it interesting.